equal to 0 minus, and another condition is at t equal to 0 plus. Okay, so tell me at 0 minus equal to 0 plus. So tell me at 0 minus, the switch was open or switch was closed? Just see the switch position. What does it mean that at t equal to 0 the switch is closed? Okay, I am writing down at t equal to 0 your switch is closed. Got it? Then what does it mean at t equal to 0 minus? Means just before that condition. Switch was open? Yes or no? Hmm? Switch is open. So at t equal to 0 minus switch is open, and at t equal to 0 plus switch is closed. Correct? If the switch is open, then the condition of this like this R L C, and if the switch is closed, then the diagram would be like this R L C. Correct? So now see what they have said for the circuit in below figure, assuming switch was open for sufficiently a long time, means बहुत पहले से the switch was open, then closed at t equal to 0. At t equal to 0 the switch is closed. The di by dt at t equal to 0 plus is, means we need to calculate the current in this, right? So as you know, if the switch is closed, then in that case it would be the charging condition or the discharging condition. Tell me. Hmm? At t equal to 0 the switch is charged or discharged? At t equal to 0, no, it at t equal to 0 is closed, right? Switch is closed, and if switch is closed, then that means supply is provided to the inductor, right? So that means if supply we are providing to the inductor, that means it is charging. So whenever we are giving the supply to the inductor, that means it is charging, and whenever there is no supply to the inductor, that means that is discharging. So in this case no supply is there, so this is the condition of discharging. Okay, in this we connect a supply, so this is the condition of charging. Got it? And I already told you that for charging, what would be the equation? V is equal to V naught 1 minus e raised to power minus t by tau if you want to calculate voltage, and for current I is equal to I naught 1 minus e raised to power minus t by tau. If you want to calculate the voltage, then it should be across the capacitor, and if you want to calculate the current, then it should be across the inductor, right? Similarly, we'll have discharging phase. For the discharging phase, we are having the formula V is equal to V naught e raised to power minus t by tau, and I is equal to I naught e raised to power minus t by tau. Correct? So again, if we want to calculate voltage, that was for capacitor, for current that was for inductor. So in this case it is charging. So for the charging, the formula they ask you to calculate current. I is equal to I naught 1 minus e raised to power minus t by tau. Correct? Hmm? So we can simply put the values over there, and I naught would be how much? They didn't give you the value, that would be V by R, right? 1 minus e raised to power minus t by tau. This they have given a second order. I think it's in your syllabus, it's only the first order they have given. Second order is not in your syllabus.